Welcome to The Explainer. Today we're tackling a huge question, something that sounds like science fiction but is based on real analysis. What if all the ice on Earth just melted? For good?
And look, the answer goes way beyond just the water gets higher. We're talking about a total, fundamental rewrite of the planet itself, a transformation of the Earth as we know it. Okay, so let's start with the big one. The number you really need to wrap your head around is this: 70 meters. That's 230 feet. If all the land ice melts, that is how much the global sea level goes up. I mean, just try to picture a 20-story building. Yeah, that high.
And just to be super clear, this isn't some minor flooding in a few coastal towns. No, this is a world map rewriting event. We're talking about entire coastlines vanishing, whole countries being swallowed by the ocean, and brand new seas popping up where they never were before. So that leads to the obvious question, right? Where is all this water even coming from? To get to that 70-meter number, you gotta know where all the ice is currently locked away. And the data gives us a pretty clear breakdown. And wow, when you look at it like this, one thing just jumps right out at you: Antarctica. It is the big one. It holds over 80% of all that potential water. You know, we hear a ton about Greenland, and that's a huge deal. But Antarctica, well, it's in a league of its own. It's the undisputed heavyweight champion of ice. All right, let's get into the nitty-gritty here. This table breaks it down even further. Look at the East Antarctic ice sheet. Just that one part holds 53 meters worth of sea level rise. It's just staggering. But here's the really critical part. Check out that mass change column. It's not just that these places could melt, it's that they are melting, and the speed is picking up. Okay, so we know where the water comes from. Now for the main event. What does the world actually look like after this? Let's take a tour of the new submerged coastlines and see what it means for all of us. The human impact is just, well, it's hard to even process. We're talking about losing some of the greatest, most iconic cities in the world: New York, London, Shanghai, Sydney. I mean, this list here, it reads like a who's who of global civilization, and poof, they're all underwater. Let's zoom in a bit to make it real. Take North America. The entire Atlantic coast, as we know it, gone. The whole peninsula of Florida, just not there anymore. Miami, New Orleans, they wouldn't just be flooded. They'd become features on the bottom of the ocean. Now, let's hop across the Atlantic to Europe. In some ways, it's even more dramatic. Think about countries like the Netherlands or Denmark. Their entire history and culture are built around holding back the sea. Well, in this new world, they essentially disappear from the map. They just cease to exist. And then there's Asia. The human cost here is on a scale that's almost impossible to imagine. You have these massive low-lying river deltas in Bangladesh, Vietnam, coastal China. The flooding there would displace hundreds of millions of people, more than any other continent. It is just unimaginable. Okay, but here's where things get really weird and, honestly, super fascinating. You'd think all this water would just spread out evenly across the globe, right? Kind of like filling a bathtub. But no. The physics of how it all works are way more complex and, frankly, pretty counterintuitive. Scientists have a cool term for it: the ice sheet fingerprint. It's this idea that the water doesn't rise the same amount everywhere. And the reason for this is kind of mind-blowing. These giant ice sheets, they're so massive they have their own gravity. And this leads to a wild paradox. So, as an ice sheet like Greenland melts, its gravitational pull gets weaker. It's not pulling the ocean toward it as much. So right there, next to Greenland, the sea level actually drops. But all that water has to go somewhere, right? It ends up piling up on coastlines far away, like in North America, causing the sea level to rise there more than the global average. Isn't that wild? And the effects are literally planetary in scale. When you move all that water weight from the poles down toward the equator, it's like a figure skater putting their arms out, and what happens then? They slow down. The Earth does the exact same thing. The planet's rotation actually slows, making our days longer. It even makes the whole planet wobble on its axis. But believe it or not, the rising water is just the first domino to fall. That initial melt kicks off a chain reaction, a whole series of cascading failures, domino effects that could make everything happen even faster. It all starts with something called the ice albedo feedback. Now, albedo is just a fancy word for how reflective something is. And as you can see here, bright white snow is like a mirror. It reflects almost all of the sun's energy right back into space. But dark blue ocean, it's pretty much the opposite. It just soaks that heat right up. And this chart really drives it home. You replace the planet's mirror with a planetary sponge for heat. So the ocean gets warmer, which melts more ice, which reveals more dark ocean to absorb even more heat. You see where this is going? It's a powerful feedback loop, a vicious cycle that just keeps accelerating. Okay, next big domino, something called the AMOC. The easiest way to think about it is as a giant conveyor belt in the Atlantic Ocean. Its engine runs on cold, salty water sinking way up north. But what happens when you dump a ton of fresh, not-so-salty water from melting Greenland right on top of it? You kill the engine. The whole system just shuts down. And a stalled AMOC isn't just an ocean problem. It's a global weather problem. This data is chilling. It shows that the shutdown would completely mess with weather patterns everywhere, causing massive droughts for the monsoons in Africa and India. I mean, we're talking about the water supply for billions of people's food. It's a catastrophe. So, we've seen the drowned cities, the weird physics, the domino effects. The last step here is to pull back, way back, and see what this all means in the grand context of Earth's very long history. And here's a mind bender for you. For most of its life, like 85% of its entire history, our planet didn't have any ice caps at all. It was a greenhouse Earth. This ice house world we live in now, with ice at the poles, is actually the exception, not the rule. So a total melt, in a weird way, it would just be the planet going back to its ancient hothouse normal. And that's the final, really sobering thought from all this analysis. The planet itself will be fine. It's been ice-free before, and it'll find a new balance. The real question is about us. That transition period, that chaotic time between the world we know and that new hothouse Earth, that represents the ultimate challenge. The big question the analysis leaves us with is, can our civilization actually survive the change?